Hi, I'm Holden Sherard. Thank you for coming. This is my 2016 presentation of learning. So I couldn't decide whether to break this down by field of what we learned or by project, so I've kind of mixed both anyway. First slide is the Wave Solar project. So I first have to explain kind of what it is in order to talk about it. So it's a solar and natural gas cogeneration engine, which means it can do not just electricity, but it can do heating, hot water, and AC if you have it set up for AC. And try not to be too technical, but we start out with some 97% efficient solar panels that absorb pretty much all spectrums of light except those that don't go through the glass tubes. Average solar panels like 20% efficient, so that's the whole advantage to those. And then short version is we convert the steam heat into water pressure. And then from there we turn a Pelton wheel, which turns a generator, and then that's where we get our electricity. We also have waste steam, which can turn, well, it doesn't turn, but it can go through your hot water heater, and it will run what's called an absorption chiller, and that will do heating and air conditioning. We did a reflector project, which was to figure out if we have just one tube, there's so much light that hits it. But if you build a metal reflector of a certain shape, you can reflect light back onto it. So we tried a curved parabola, and Ed had a not patented upside down McDonald's end looking thing. I can't get into the specific geometry of it. But essentially the idea with Ed's shape is a parabola will deliver light to a specific single point, which you can melt a lot of stuff with it. But we had an entire tube, so he wanted to deliver with any angle of the sun relative to the tube. You can get 90% of the light that hits the reflector onto your heat source. Hold on, back that one up. So some pictures of it. So this is one of the Pelton wheels. This is not actually ours, but it's one of the kind of turbine that we use. I think it was invented like 140 something years ago, and it's still like one of the 97% efficient water turbine. This is the engine, so you can see there's the turbine. We have tank, reservoir, and also condenser there. A couple other things behind it, but they're kind of small. Better view of the turbine. This was a picture of us at the Inventor Showcase Maker Fair, and Ed in his very patriotic shirt. And then this was a problem we had where we had a float level sensor in the boiler, came off and got stuck. A little plastic thing got stuck down in one of our valves. So we spent about an hour trying to open every single of 6 valves and find which one it was, and it was like the fourth. Of course, it's always almost the last one. More pictures here. You can see the reflectors test. This is my parabola and Ed's upside down McDonald's M. This is one of Ed's. Mine are not near as pretty. It's a TIG weld, tungsten inert gas. I'll not get into too much about welding, but had a lot of trouble with those. But this is a relatively nice one. This is the electrical control panel of the Wave Solar, and this is another picture of the engine. Here you can see one of the water pistons, which we use to convert steam into water pressure, and then the boiler, as well as some pumps and things for refilling. Keeps doing that. A little bit about the Ammonia Chiller. I learned how one of those works, so try not to be too technical, but eventually, well, not eventually, but what happens is you have ammonia in a water solution, and what you do is you have the ammonia absorb heat out of that, and it evaporates, and that takes all the heat that it absorbed with it, and then you take that, condense the ammonia, and then that puts the heat back out, and you of course condense it in areas so that you radiate that heat not into the area you're trying to cool outside the house or refrigerator or whatever the unit happens to be on. And you have to reabsorb the ammonia into the water to continue the cycle. Little side project we worked on was a fire tornado for the Maker Fair. This is a cool picture. It looks really good at night, but we debated about building a Rubens tube, which is another cool fire thing. But we went with this instead because, you know, it had a lot more fire and cool factor. You know, tornadoes made of fire, but essentially what this is it's just a stainless container surrounded by 6 mid-sized electronic computer fans. So those turn, and then you get kind of a cyclone of air going up around your vat of liquid fuel, alcohol in this case, and then that is what creates your fire cyclone. Also learned about different kinds of alcohol in that. Turns out isopropyl is cheaper, but if you want to turn the color blue or green or something cool with a different pigment, you need something like methanol, which does not burn with any kind of pigment. So machining. So this is, if you have a chunk of metal and you have drills, in mills, whatever, and you remove material until you get the part you want out of it, basically carving metal, and it works on wood and plastic as well. But I took a class about it at Thompson Valley High School. It's not totally related to what I'm doing with E3 and Ed, but it has become very useful in that. I worked at Loveland Creator Space with Ed and another machinist doing some parts for our wing. I think I might have pictures of those. So from that I learned G-code commands, which are kind of the language that the computer CNC machine, computer numeric control machine, uses to move around and cut stuff, and some basic Mastercam, which is the program you use to convert like a 3D file, CAD file, into actual, here's how we produce it things. The Creator Space now has a CNC router, so I hope to use that. Slightly different software, but similar. Another software is called CamBam. I've briefly tinkered with that one, and then I also, for a different project, had to learn to export a DXF file. It's a common carrier file for AutoCAD and various 3D design programs, and import that into a laser printer and learn to use that. So welding. So this was another thing that was both in the class at TVHS and that Aerodynamics worked on. So there's three main processes that are used today for welding, for hand welding. There are other, spot welders and friction welders, but those are very specific. One-use high-tech machines. They're not so much near versatile of what we need. There's TIG, which is tungsten inert gas, which basically means you have kind of a torch, and it's not really fire, it's an electric arc, but at least you can, for the most part when you're welding, you can just say it's fire and it looks the same. You have your two metals that you're trying to weld together, and then you have a filler metal which you add because as you try and melt stuff, it kind of burns off some of the metal, so you need to add some more. MIG welding, which rather than having a separate torch and filler rod, the filler rod becomes your torch. A little less versatile than TIG, but it still works pretty good. And then you have arc, which is it's a pretty dirty way to weld, but it works and it gets the job done. And that is where you have a metal filament, and then you actually coat it in something, because when you heat your metal up, it likes to oxidize and burn. So with TIG and MIG, you have an argon or an inert gas surrounding it, but with the arc rod, you just have the flux coating on the arc rod burns off and kind of creates a shield. So you don't need anything but an electric arc. So practiced all three methods between Wave Solar and TVHS. Mostly did TIG with Ed. The TVHS does not have a TIG welder that I know of. And but TIG welded a lot of stainless. It's pretty cool. Also very difficult, surprisingly difficult to do. But the Aerodynamics wing project, there was another project, this is a project one, where we built a wing for Ed's sailboat, because a sail, if you actually study airfoils, sails are not very efficient. So what we wanted to do was put a wing on it, like you would see from a wing on an airplane, but vertical so that you would move forwards as to up. The only problem is eventually we want to build a fancy boat and break the world speed record for sailing, but the problem with that is in order to do that you need to be able to go one direction and then somehow come back. Well, if your wing is just mounted to your boat, there's no way to do that. You're only going one direction. You can't spin the wing. So what we figured out how to do was you have the mast in the sailboat, you put the wing on that and flip it over, and that is how we're going to do that. So I did with the machining, I machined the parts to mount the actual wing, which we had already built previous year, but to mount that to the mast. And I also learned a program called OpenVSP. It's a NASA program that does, you can do airfoil design, so wings, and you can do an entire aircraft too, so it doesn't just do wings, it does fuselages, tails, propellers, whatever you want. It's a pretty cool program, but I'm not very good at it yet, but learned a good bit in that one. We did mostly focus on other projects. We didn't have time to do a whole lot on that one with Wave Solar and the other stuff. So, but it's getting warm, the lake's thawed, so hopefully we'll get back on that one. Decided it was time, learned a lot of physics concepts from wave solar, but time to start getting the math caught up to that. So we didn't get terribly far with it. We did Newton's laws, so inertia, which is everything has a resistance to change its speed. The second law is just kind of defining force, so it's the mass of the object times the acceleration you give it is force. And then you have, if I push on an object, it pushes back with an equal amount of force, action, reaction, how a rocket works, all that stuff. And then the other thing was what a differential equation is, and understanding and approximating it through Excel. So what a differential equation is it's something where, like, if you say you have a curve on a graph, and you want to figure out the area of that curve, what you have to do is calculate the height, and then calculate the height at a different point, and then the height at a different point, and you can do so many points until eventually you will get a pretty accurate picture of your area. What a differential equation allows you to do, rather than just doing an equation for every centimeter or millimeter or whatever, it allows you to do every single point along the line with a fancy math equation, which I don't have the actual algebra to do that, but you can use Excel and just do the point by point and at least understand. I tried to get a spreadsheet, but for some reason Excel does not like to copy into PowerPoint, so it's saying there's an invalid reference, but the calculations are fine. A couple other oddball stuff, just talking radial versus axial turbines. So Ed previously worked on a company called VanDyne Super Turbo, which I worked on a little bit, not a whole lot, but essentially for that, and I'll not get into the details of that because it's not really relevant here, but he uses a radial turbine, which is not what you would see, like say in a jet engine, where you have a steady fire which just burns and produces pressure. The radial turbine works by taking exhaust puffs out of an engine, just boop, 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 you know, which is not a steady state combustion, and it can handle that without disrupting the flow over the blades. Unfortunately, it's really hard to describe a radial turbine without having one, and all of the radial turbines that we had were either made on really nice 3D printers or selective laser metallurgy machines in Inconel, which is not a cheap metal, so I don't have one, unfortunately. About $500 for a little 4x4 chunk. Yeah, that was a particular one. If you order it in bulk, it's cheaper. And then of course some more combustion stuff. So this was something I didn't know before. If you have a cylinder, like in a car cylinder, and you fill it with gasoline and ignite the gasoline, you produce a bunch of heat. Well, the problem with, and that works great, but the problem is right next to the cylinder wall, you have a layer of gasoline, which rather than getting hot enough to burn, exchanges all its heat into the side of the cylinder and doesn't actually burn. Now, there's not really any way to fix that, but what you can do is make the area, the surface area of the cylinder, as small as you can get for a given volume, and that will minimize that loss. And of course, that's the reason why something like a rotary engine, which has lots of moving parts and a great surface area and a lot of complicated stuff, apart from being very difficult to produce, is also very inefficient because the great surface area, a lot of unburned gasoline. Read pretty much every Wikipedia page for common metals and alloys and some of the cool super ones too. Learned a lot about different metals and metallurgy on my own, which of course has played into wave solar a good bit, learning about stuff, you know, heat exchange. We had to get a heat exchanger, and you would think you'd make something like that out of stainless steel to withstand the combustion products that you're about to flow through it, but what you actually would sometimes make it out of is brass, because the stainless would be resistant to the corrosion, but it would not transfer the heat through it well. So I learned a little bit about heat exchange and what metals you use for that. And I predicted copper tungsten. So we got into talking about building nuclear aircraft, as most engineers get into stuff like this for whatever, for whatever reason. And so we started thinking, rather than building a metal or a graphite container that when you have your nuclear is no longer cooled by coolant, then it just heats up and melts through the container, build it out of something that would have, use a light fissile material which does not get that hot, and then also build it out of a material that has a great deal of heat response, or heat capacity, so that it doesn't get burnt. That said, you also need to get heat out of the nuclear reactor in order to get energy from it. So the alloy I found for that was called copper tungsten. So copper has a very good heat conductivity, and the tungsten has the heat resistance. Combine the two in a certain proportion, and I haven't calculated that, but you would be able to build a nuclear reactor out of it, and of course discussed how to build nuclear aircraft. Somehow we haven't found the funding for that one yet, but anyway. And finally, some to-dos. So Ed is going to Burning Man, and he is, yes, Ed's going to Burning Man, and he has gotten a $3,000 contract to build like a 30-foot wide Da Vinci kite. So it'll be made out of materials only Leonardo da Vinci could have built, and it'll kind of, we're going to try and make it look with the wing profile like a Da Vinci aircraft, but also to have the Bernoulli principle rather than just like a sail, but an actual wing shape to it, so that it can, of course, get off the ground and not just be ridiculous looking and cool. And then, of course, learn to use the CNC router. I already talked about that one for a different project, MakerCard project, Ed's working on. I need to learn SolidWorks. SketchUp is good, but some of the DXF files and stuff it exports to go through G-code programming for machining, those programs will not accept the SketchUp DXF, so it looks like we're probably going to need a different design program. Tried AutoCAD, don't like AutoCAD. Ed doesn't like AutoCAD. AutoCAD, terrible. Not going to market them. So try SolidWorks and learn to use that. And then I do not know enough about electronics. Need to get better at that and become more fluent in that. So we covered some of the basic, what each part is and what it does, but you know, we covered sensors that measure stuff. Well, there's about 1,000 different kinds of sensors, so need to get into each of those 1,000 and how they work and stuff like that. So, any questions? Okay.
Tell us.
Second.
Wait a second.
Can you talk a little bit about, because you've been in E3 quite a while,
Right.
talk about how that's worked alongside you being in high school, because I know that's a new thing for you.
Alongside me being in high school, part-time high school, the high school has more worked along E3. So I'm taking a couple of classes there which are just social studies and aren't really relevant to this at all. Just one really, but the rest of them have all been computer programming and mechanical or drawing that can be applied to mechanical drawing and machining, welding stuff. So all of that gets utilized with the Wave Solar, so I'm not sitting there trying to TIG weld with Ed. I'm not, how's this work, huh? What's tungsten? I kind of know how it works, and then I actually understand what I'm doing and I'm able to practice it.
So, in addition to that, I have the unique perspective of having known you for a very long time and having been your teacher in another capacity when you were much younger. And you were out of public school for quite some time, and this was your re-entry to school. How did that work for you, having been away and then back?
It worked fine. It wasn't I have to sit at a desk and do stuff. It was still learning the way I'd been learning at home, which was, you know, work with somebody, in previous cases, even my dad or somebody else, but to actually learn to do something by doing it rather than just reading it out of a book, doing some stuff on some paper and moving on. You actually learn how to do it. You can't just read a welding textbook and be able to weld. You have to weld.
Right.
And then maybe read the textbook. It really just all comes down to practice. So it was good. I've been able to actually learn with my hands and actually do stuff and see what professionals do.
And you are still considering that as your main pathway for career choice?
For career choice, yes. Engineering. Hopefully, not sure about an aerospace major just because the job opportunity is more limited, but like mechanical engineering with a minors in aerospace or something like that. Work on airplanes. Airplanes are cool.
Are you still doing your Young Aviators?
Still doing Young Aviators. Stuff with that is kind of slowed down. Their big B-25 project has mostly been finished up, so B-25 Mitchell Bomber project, I should elaborate, but for the most part, yeah, I'm still working with them and doing stuff, so.
So you have other extracurricular things that you do too. Can you talk a little bit about all those things that you bring to?
Other extracurriculars, so that would mostly be the Young Aviators. So what Young Aviators, yes?
Guitar.
Okay.
And 4-H.
Guitar and 4-H. So 4-H, there's a whole lot about 4-H, so it's kind of an opportunity. I take dog training and then archery, as well as I picked up my uncle's great uncles, great grandfathers, somebody's old muzzleloader for deer season, hunting rifle, black powder muzzleloader gizmo. So I've kind of been playing with shooting that a little bit. Not very good at it, but archery and dogs. So it's a good opportunity to get experience with, you know, whatever you're interested in, and it's not just a career-specific thing, which E3 like doing it, but so far it has been very career-specific. The 4-H just allows you to get better at the stuff you like doing.
And you've won some awards in both of those
Both
projects.
of those, I don't know exactly what offhand, but dog, 90% the dog, about 10% me, and about 5% of me has been messing up. He's placed, except for the one time we did showmanship, he's placed in the top 5 for like 3 different competitions, so it's pretty cool.
In your archery, you hold a state title for that? Is that
State
right?
title, sort of.
He's Larimer County's #1 archer.
I'm the county archer. So the tricky part with that is I went to the county shoot and I shot first and second, I think 3 years, no. First year I didn't place, and then next 2 years I shot like first, second, or third the next 2 years. And the second year we decided to go to the state competition down in Pueblo. It's hot, it's a desert. Well, guess what? If you've been sitting in the desert for about 5 hours, it's kind of hard to hold still and shoot something. So didn't do so good at state shoot, but the county, in the past couple of years, I've done pretty good in archery. And this is first year in muzzle loading, so haven't used the muzzle loader at all and haven't really gotten good at it.
So if you go to the state archery competition this next time, what did you learn from your previous team?
Bring an awning and a lawn chair.
Come prepared.
Yeah, also, don't hang out in the desert. But yeah, I probably wouldn't go to state. It's not that fun. It's lots of waiting and driving and very little shooting. So, you know, I just like to hit stuff. I'm not real concerned about showing off.
Other questions, comments for Holden?
I have one, but I'll let the ladies go first. They have one.
I was excited to hear you say you were going to go into mechanical engineering. I think that makes a lot of sense and gives you a lot of opportunity. Right. What path do you think you'll take from after you're done with E3 in high school? Are you going to go to a traditional type college? Are you going to look at some other options? Where are you going to go after
So, I have to say, if you're applying for a job, having a college diploma really helps. You might know it, but you have to be able to prove you know it, so college is definitely something we want to look into, but probably go to a traditional college just because Dad's not an engineer, Ed is, but he doesn't have time to teach, 8 hours worth of classes a day or do a whole, it just wouldn't work. But the other thing, being an E3, rather than looking at how do I graduate from high school, it's how do I get into college, which is the important thing because those two requirements probably don't match. So if you want to go to a certain college, look at what it takes and know if you want to go there or not before you take all the classes.
Give an example.
What do you mean an example?
Well, like when we went to mines, what did we learn at mines?
So, I don't understand what you mean.
So I'm probably not phrasing it well, but the difference between the community college classes and the AP classes, for example.
Okay, so what she's referring to is the fact that, for instance, we looked into taking some classes at Ames or Front Range community colleges and getting college credit for them, so I wouldn't have to take, I could already weld if I went to mines, or I could have a machinist certificate, or I could have, computer programming, math, whatever it might be. But you have to look into the fact that whether or not the college classes, those credits, you might have learned the information, but they might not be accepted by the college, or whatever else it is you're trying to apply for.
So on that same thread, have you picked kind of where you might want to be going and kind of
so
backward
Boulder
plan?
or mines?
Okay, good. So you can kind of
Yeah.
backward plan from
One
there.
of those. MIT would be cool, but it's a bit of a drive, and
Yeah.
Boston.
It
And,
really is.
nah. So,
Awesome. Thank you.
So my question, Holden, was that you did a ton of stuff this year,
right.
right? I mean, just there's barely enough space in the rubric to write down all the things
She's
you're
gonna give
working
up.
on, right?
I know.
I'm curious, which one of those things, whether it was the wave solar, the reflector, the ammonia chiller, the fire tornado, the machining, or the welding, which one of those things was most difficult for you, and how did you cope with some of the challenges of learning?
The most difficult. So with the machining, the Thompson Valley machining was not computer controlled, it's manual, which is really nice because you can kind of see what you're doing and control the whole thing without having to be computer CNC literate and trying to debug code, and you can see what's going on and you can understand the whole, here's our work and here's our cutter and here's what we need to do without having to be all computer literate. With the Creator Space, I started out with no experience at TVHS going CNC at the Creator Space. And I learned a lot, but it would have been more beneficial to start out just doing stuff manually without trying to just learn how to, how to align a vise and indicate something and use parallels, rather than, okay, here's a whole bunch of computer programs that you don't know how to use and don't like using because they're difficult and I have trouble with them, and put those in a machine you don't know how to use. If I'd already known how to use the machine, the computer would have been much easier. So that was the difficult part of machining. Welding just comes with practice. It's difficult to make it pretty, but the other thing I would probably have to say is the ammonia chiller was difficult to understand, and it's not a huge part of the machine yet. We don't actually have one on the working prototype just because we don't really need it. We're just worried about electrical efficiency and some basic tests. But production version, understanding how one of those works and how you can use one to, at least in the winter, to kind of cool the cold and do something weird to get 135% efficient, which sounds like a pseudoscience because you can't get over 100% efficiency, but in this particular case you can. How to operate the ammonia chiller in order to do that was really confusing to me.
So Holden, the time requirement each week for E3 with your mentor is 3 hours. Can you address the time that you spend with Ed on a weekly basis?
Tuesdays I'm with him from 11 till about 11. And then Saturdays we work on both wave solar and the and personal projects like the wing or the fire tornado and stuff as well. So I probably cover a full day a week with him, 24 hours, so way more than enough.
So what's your takeaway from that experience?
Apart from some advanced math and stuff, I've kind of learned how to be an engineer. The whole way Ed, we need to get more into patent filing, but for instance, the whole way Ed does stuff, like for instance, there was a guy who had a cool welding robot where he was basically trying to turn the welding robot into a 3D printer, where you extrude hot metal and build up a part with no mold. What Ed suggested was, rather than just building up metal, also take your welding wire, tack it on here, extrude the welding wire, and use it as a tension. Now, of course, in order for Ed to do that and have the discussion about that, he would go talk to the guy and hopefully get hired as a consultant. Well, if the guy just decides that, that's a great idea, I'm going to go take it and cut you out of it. So that's why you have a provisional patent already filed on that technology, so if he tries to go around you, you're like, actually, I have this, hire me. So stuff like that where you really have to not just be able to file a patent, but know when and how and stuff like that.
So you've learned the business part of being an engineer.
More of the business now that Wave Solar has become more of a company and gotten some contracts and stuff. I've learned a lot more of the business side of it. Not great at legal writing. Nobody is. Nobody likes it except lawyers. They're crazy. But
so where do you see yourself going next year?
next year, another E3 program, of course, and then probably I will take some computer programming, maybe machining, welding, depending on what happens at a community college, as well as more machining and manufacturing classes at Thompson Valley.
And I don't know if they have AP classes in machinery and that kind of stuff.
I'm not. Yeah, it's not really.
Okay.
So the beginning welding and arc welding is actually through Thompson Valley for college credit.
Okay.
Yeah.
But is that is concurrent enrollment
Yes.
instead of AP?
Right.
Oh yeah.
It's not an AP class. No, it might be college level, but welding is welding. You can learn to weld when you're 80 or 8. Doesn't matter.
So what I guess my point, because last year you were really focusing on that whole the sailboat and trying to get the fastest sailboat. So it's fascinating to hear how you've engaged and explored and expand your research there. That now instead of having the wing as the sail, it's now you're putting it on top of the sail or the mast.
Right.
And so in 365 days and you're ready to do your next presentation of learning, what do you predict you're going to be bringing back to us to share how you've expanded your learning nowadays?
Hopefully Wave Solar will be in production with at least the beginning production version by the end of this year, so I'll have stuff about the final version of that when the patent on that specific thing is filed, more about the ammonia chiller and more of the systems on that, as well as how you actually get a product into production, because of course it wouldn't be practical to hire Ed and Ed's engineers to go build these things, 10 in a day. It's just not practical, but how to get a company to manufacture that and get it assembled and get it done without having a huge, massive startup cost. Stuff like that. I'd also like to see the wing get on the sailboat, because that would be fun. Need to do some machining for that, which we haven't found time to do, and need to get a chunk of aluminum for that. But I think we can get the wing with the skin on it and mounted on the mast in the sailboat by probably next year.
I think we let the kid off the hook, man.
All right,
For half an hour.
Outstanding. Thank you so much.